Hello, Namaste, Konnichiwa. Welcome to Sunny Sensei. In this lesson, we'll prove the law of cosines. For a triangle ABC with sides A, B, and C, and angle C opposite to side C, the following is true. C square equals A square plus B square minus 2AB cos C. We start by drawing AD perpendicular to BC. Angle ADB equals angle ADC, both at 90 degrees. Now, consider triangle ADC. This is a right-angled triangle. So, applying Pythagoras theorem, we get B square equals AD square plus DC square. Next, consider triangle ADB. Again, a right-angled triangle. Applying the Pythagoras theorem gives us C square equals AD square plus BD square. Now, from equation 1, we can replace AD square with B square minus DC square. And we have rearranging the terms gives us BD plus DC is A. So, we can replace BD with A minus DC and we get C square equals B square plus A minus DC whole square minus DC square. Or we have the square of A minus DC minus square of DC. So let's apply the identity. X square minus y square equals x plus y, x minus y. And we get A minus DC plus DC times A minus DC minus DC. Cancelling out plus DC and minus DC, we are left with. Now, cos of angle C is DC by B. So, DC can be replaced by B cos C. And finally, we have C square equals A square plus B square minus 2AB cos C. With this, we have proven the law of cosines. But before we wrap up, let's have a quick look at this equation. What happens when angle C equals 90 degrees? Cos of 90 degrees is 0. So we have C square equals A square plus B square. This is the Pythagoras theorem, a special case of law of cosines when the triangle is right-angled. If you enjoyed this lesson, don't forget to like, share and subscribe to Sunny Sensei. Thank you and see you again soon.